So October, November 21, P31. Question number 1. Numbers are stored in a computer using floating point representation with 12 bits for the mantissa, 4 bits for the exponent, 2's complement form for both the mantissa and the exponent. Write the normalized floating point representation of the following unsigned binary number using this system. This is fixed point. This is fixed point. We have to float the point all the way towards the left. ठीक है? तो जब हम इसको fixed point से floating point करेंगे, तो then we will have mantissa and exponent. So we have to move the point all the way towards the left. So this would become 0.10111000110001, and the point moved 1, 2, 3, 4, 5, 6, 7. This will be its exponent. Okay, this will be the exponent. Now, this is mantissa, this is exponent. Now let's write the form, which is 12 bits for mantissa. So we fill the mantissa from left to right and exponent from right to left. So first 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have lost basically is it 11 or 12? Sorry. So let's count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 bits for mantissa. So we have lost these two least significant bits. And then we have got 7. 7 for 4 bits. So 1, 2, 4, 8. So this is your answer. 0, 1, 0, 1, 1, 1, 0, 0, 1, 0, and your exponent. This is your exponent, and this is your mantissa. We fill mantissa left to right and exponent right to left. Remember that. So 0, 1, 0, 1, 1, 1, 0, 0, 0, 1, 1, 0, and 0, 1, 1. We have actually dropped these 2 bits. They got dropped. Why? Because of the less space. Okay. Now, state the consequence of storing the binary number in part A1 as floating point number in this system. Justify your answer. The precision, which is accuracy, has been compromised. It is reduced because of the less number of bits in mantissa. So the consequence was the precision or the accuracy was reduced as 2 bits from least significant bit side got dropped. All right, so this is the consequence, and this is basically the justification. Okay, so the precision and the accuracy was reduced, and the justification is as 2 bits from the least significant bit side are dropped in mantissa. If you want to be very specific, then you have to tell that in mantissa. Okay. Explain the reason why binary numbers are stored in normalized form. Normalize. Why do we normalize? So that we may have as many bits in the mantissa as possible, because mostly the overflow issue does not occur with exponent, rather it mostly occurs with mantissa. So why do we normalize the number? To store as many bits as possible in Mantissa uh, by removing any uh, consecutive leading zeros, leading or zeros on the most significant side, consecutive zeros on most significant bit side, and adjusting exponent accordingly. This gives maximum accuracy possible for the given number of bits. Given number of bits, and enables us to store maximum number possible. All right. So explain the reason why binary numbers are stored in normalized form: to store as many bits as possible in Mantissa by removing any consecutive zeros on most significant bit side and adjusting exponent accordingly. This gives maximum accuracy possible for the given number of bits and enables us to store maximum number possible. All right. Now, draw one line from each programming paradigm to its most appropriate description. Remember, we have studied four programming paradigms: declarative, where we use facts and rules; imperative, whatever that you have done in P2, that was all imperative; whatever that you have done in low level as far as the opcode and operands are concerned, that is low level in chapter 4. Object oriented is also imperative, but it is actually a different programming paradigm, but it is imperative. Object oriented comes under imperative paradigm, but in our syllabus it is regarded as a separate one. So programs using instruction set of a processor, programs using instruction set of a processor. So this is basically low level language. Programs based on events such as user actions and sensor output. Leave it out because this seems like it is monitoring and control description. Programs using the concept of class, inheritance, encapsulation, and polymorphism. So this is object-oriented. Programs using concepts of, programs using concepts of class, inheritance, polymorphism, etc. Programs with an explicit sequence of commands that update the program state or with or without procedure calls. So this is basically declarative. Programs with an explicit sequence of commands that update the program state with or without procedure calls. So this is declarative. Programs that specify the desired results rather than how to get to it. I think I have made a mistake. This must be programs with an explicit sequence of commands such as imperative, because declarative does not have procedures and functions. So programs that specify the desired result rather than how to get it. So this is basically based on rules and facts. So this will not be used because this is monitoring and control. And it is not mentioned over here. All right. Enumeration, enumerated, and pointer are two non-composite data types. This is chapter 13. Write pseudocode to create an enumerated type called parts to include these parts sold in a computer shop. So this is type parts. Enumeration means a list. List items do not have any type, remember. So we are not going to put them in double quotation or single quotation or hash or whatever, because list items do not have any type. List itself is a type. So the name is parts, type parts. We start bracket and we will put all these: monitor, CPU. These values are not of any type, they are just the values. So that is why we don't put any double quotation or anything. Remember that. I reckon. SSD, HDD, laser printer. And try to notice that these values, if they have got two words like this laser printer, they haven't left any space in it. So whenever you put a value inside a list, make sure that those values do not have any space. Keyboard and mouse. All right, so this is basically the type, enumeration type, non-composite. Non-composite means those types which are not made up of any other types. No, Ahmad. No. All right. No. Yes, at most you can do that, you can put an equal to. Okay, that's it. Enum is in Visual Basic, my dear. Number 3B, write pseudocode to create pointer type called select bars that will reference the memory location in which the current part name is stored. Remember, when we create a variable of this type, this pointer will be pointing to the location of that particular variable. Okay, so we be like type. This is pointer type. Pointers do not, you see, in computers memory, we have got two things: addresses and data. So address 1 has data 3, address 2 has data 5, address 3 has data 6, address 4 has data 10. So pointer will be telling about the address and the variable will be telling about this data. So pointers do not tell us about the data or the variable's value, rather they tell us about the location of the variable. So sales parts, select parts, sorry. Select parts is equal to location of, this cap is basically used for location of parts types. Okay, so select parts is equal to location of parts this type. Now, this is a syntax diagram. The following syntax diagram for a particular programming language shows the syntax of a digit, a capital letter, and a character. So digit can be any digit from 0 to 9. Capital letter can be any vowel. You see, A, E, I, O, U, and character can be. Sir, if the cap is after the variable, what does that mean? That is basically means that we are now want to have the value at that location. So if you are accessing location, you use cap before. And if you want to get the data from that location, you use cap after. Okay. All right. So characters are dollar, percentage, ampersand, and asterisk and hash. Write the Backus null form notation of the syntax diagram for character. So character is defined as character is defined as a dollar or percentage or and sign or an asterisk or a hash sign. That is how it works. Okay, so this is basically syntax diagram. Okay, now part B. A password must begin with a character and be followed by one or more digits or capital letters. State the example of a valid password. Must begin with a character. So we have got A, E, I, O, U. So let's take U. Followed by one or more digits. So 1, 2, 3, 4. Or capital letters. One or more digits or capital letters. So this is a good thing. You one or more digits or capital letters. So this could be U1, 2, E, 3, 4, I. It could be like that. All right. So a password must begin with a character and followed by one or more digits or capital letters. So these two are fine ones. Okay. So here in this syntax diagram, it says that password is a character. After that, you can choose any of the digits and the capital letters together. With the BNF notation, the syntax for the password, write the syntax diagram, write BNF. Okay, so password is defined as X or Y. First of all, we have to have a character. So it is defined as a character followed by X. X is defined as a digit or capital letter or digit. X is defined as a digit or capital letter or any number of digits, digit X, or any number of capital letters. Or capital letter X. We can break this up in the form that X is defined as P or Q. P is defined as digit or any number of digits. And Q is defined as capital letter or any number of capital letters. So it's up to you, either you go by this or this part. Okay, while this remains fixed. Okay. Now let's take questions, sir. If we have to start with character, star or so we have to start with a character. So this is the character. This is the character. Okay, so we will write this line, then this line. This is B1 or this line. These three lines basically. This is B2. Either of these two. So it will be password is defined as character and X. Here X is defined as digit or capital letter, digit, any number of digits, capital letter, any number of capital letter. Or instead of this complicated line, you can go like X is defined as P or Q. P or Q. P is defined as a digit or any number of digits, and Q is defined as capital letter or any number of capital letter. Sir, in the previous part, you started with a capital letter instead of a character. Okay, but over here we are only defining this. A valid password represented by a syntax diagram, this one. Write the BNF notation of the syntax diagram for the password. So we are not concerned about what we have done before that. Get the idea? Compare sequential and serial methods of file organization. All right, so both are text files in which records are records are saved rather saved we use append in chronological order. All right. When accessed, they are both accessed serially for records one after the other. Okay. Sequential files when saved they have a sequence, they have a rather order of some sort, like serial number, in sequential file algorithms are written algorithms are written to make arrangements, to insert record at required location. So see, in sequential file there are two Ahmad, you said that this one is wrong. This one is wrong, Ahmad. So in the previous part, you started with capital letter instead of a character. No, I started the password as a character and X. And then I explained X. X is this. I made this X. And then I took it once digit or any number of digits. Here digit and any number of digits. And then I took it second, a capital letter or any capital letter or any number of capital letter. Then I separated them, these two, into this is P and this is Q part. And I did it separately over here. So you can choose. It is not wrong, it is correct. All right, compare serial and sequential methods of file organization. Both are text files in which records are appended in the chronological order, but you need to understand that sometimes sequential files are over the direct access medium. All right, so they can be accessed directly if they are saved over the direct access medium. When accessed, they are both accessed serially for records on one after the other. Sequential files, when saved, they have an order of some sort, like serial number. In sequential files, algorithms are written to make arrangements to insert record at the required location. So if you like to add a record, what you do, you basically go to that particular location and then you check if the record is entered at this location. But since you cannot do it, so what you do, you open another file, transfer all the records before it to that new file, then your new record and all the records afterwards from the old file. This way you will be having a record inserted in between records. Okay. Now, state the most suitable method of file access when a record is referenced by a unique address on a disk type storage medium. Disk type storage medium means direct access. So this is basically direct. When you can reach a record by having its address, this is direct access. State the most suitable method of file access when a bank stores its data records in ascending order of the account number. So this is sequential access. All right. Explain how packet switching is used to transfer messages across the internet. So we have to actually describe that we have got some data that our computer divides into packets, and those packets then get stamped with the origination IP and destination IP along with the payload, which is basically the data for that chunk. They are sequenced and then they are sent out. When they are sent out, on the way to the destination, different routers route them from different locations. This way they get scattered all over the internet. Once they reach to the destination, they might come in not in an order. So in that case, the sequence number that we put over the packets is used by the destination computer to put them together to form the same data as it was actually started. Sometimes packets get strayed, they become stray packets. So they are also stamped with a hop number. Hop number is the estimation of number of times that particular packet will hop over different routers. So every time a router is accessed, router decreases the hop number. So if, God forbid, the packet becomes stray and it does not reach to its destination, then the last router that sees that the hop number has reduced down to 0, it kills that packet. In that case, the packets are resent. So any stray packets are killed by the routers and they are resent. Okay, so this is all about the packet switching to transfer the message across the internet. Since it is 5 marks, we would have to write it in detail. A message, we have to use the word message is divided into a group of chunks of equal size